In this video, we will do another valid-invalid argument example. So the example says, convert the verbal argument to symbolic form, then determine whether it is valid. Okay, so the statement is, if there's a game tonight, then I will watch it and order pizza. I ordered pizza, therefore, there's a game tonight. Alrighty, so I need to convert this to symbolic form, so let's first assign some letters or labels to the propositions. So this talks about there's a game tonight. I'm going to call that G. G is going to be the proposition there. There's a game tonight. And then after the then statement, I see two things. I see I'll watch it, and I see I'll order pizza. So let's let W be I will watch it. I will watch it. And let's let P be the proposition I order pizza. So now that we have propositions labeled for each item in this argument, let's put the argument into symbols. So we can write this argument in symbolic form. So when we do this, I'm going to be careful to distinguish the givens, so what it is that I'm given, from the conclusion. And I think the conclusion's easier. It says, therefore, there's a game tonight, which means the conclusion is just G. We're trying to conclude whether G happens. And then what are we given? There's this if-then statement in the first sentence. If there's a game tonight, then I will watch it and order pizza. So I need an implication. So it's if there's a game tonight, which means G is the first part of that. And then the then part is something and something. So I'm going to need a parentheses and then put something and something. So I will watch it as one part of that, which is W. And I'll order pizza. So P, that's the second part of that. Okay, so that sentence gives me one of the givens, but there's another sentence that corresponds to a given, which is I ordered pizza. And that is proposition that I labeled with P here. I'm not going to worry too much about the tense, like I order pizza versus I ordered pizza. I'm not going to worry about that really. So I'm still going to just call this P. So now we're ready to test this with a truth table. So test it with a truth table. All right, so we had these three initial propositions. We had G, W, and P. So I'll put a horizontal line. I'll put a double vertical line to separate these. And let's build out the rest of this. So we need W and P. We need G implies W and P. And then I got to do G implies W and P and P. So this is forming all of the givens together in an and statement. So once we have those, I do that whole thing, implies my conclusion. So G implies W and P. And P, this whole thing, let's put a bracket around it, this whole thing needs to imply that G happens. So let's make this truth table. So from here, I want you to try it first. Pause the video for 3 minutes to practice this truth table, and then from there, determine, well, is it a valid or invalid argument? 4, 3, 2, 1, pause it, and try to do this truth table for about 3 minutes. Alrighty, so hopefully you did that. Hopefully you paused the video and tried this for 3 minutes. I'm going to go through this more quickly because we've done a bunch of these truth table examples now. So I'm going to just fill some of this out already. Alright, so I've gone ahead and filled out the values for G, W, and P. Remember, with P, I'm just alternating true, false, true, false. With W, I alternate double trues, double falses. And for G, I will alternate 4 trues and then 4 falses. All right, so next I'm going to fill out W and P, but I'm going to do this one really quickly again, just like I did before. So this one is only true, an AND statement is only true when W and P are both true, and I fill those out. And all the rest of these, at least one of them is false. So that'll make the whole AND statement false. All right, so I've gone ahead and filled in those falses. So now let's move on to this next column. G implies W and P. So I have to look at G and I have to look at W and P, those two columns. And the only way for this implication to be false is if G is true, but the W and P column is false. And that happens in this row, this row, and this row. G is true, and the AND statement is false. But in all of the other rows, that doesn't happen, so all of those are going to be true. These are all trues. Okay, next column involves the previous column, and then AND P. So for that AND statement to be true, both P, and this column need to be true. So let's see, that happens in the first row. P and then this implication are both true. It happens in this row. And it happens in this second to bottom row. But in all of the other rows, that doesn't happen. At least one of those is false. So we'll get the rest of these are false. The rest of these are false. And then finally, we put it all together and we have to do this big thing, which is the previous column, implies G. So the only way for that implication to be false is if this column is true and the G column is false. So let's see, does that happen in any of these? So this is true, but that's true, that's fine. This is true and that's false. So that would make the implication false. And then this was a true, oops, I forgot to finish this F here. Okay, and then this was true, and then G was false, which means the implication is going to be false. But the rest of these are all true. So, whoops, let's space these out a little bit better. True, 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 and true. So, our conclusion is, since this proposition, G implies W and P, that whole thing, and P, those are all the givens. Let's put a big old bracket around them. All those givens implying G. Because this is not all true, it's not a tautology. Some of these outputs were false. This argument is invalid. This argument is invalid. And that is our answer. So in terms of our goals for this section, we have finished our first goal to determine whether a logical argument is valid or not using truth tables.